A catastrophic earthquake in the Pacific Northwest would topple buildings and bridges, not to mention the damage from a tsunami.
Satellite imagery combined with geophysical measurements recently revealed a disturbing alignment between the Cascadia Subduction Zone and the Yellowstone Magma chamber. The United States Geological Survey marked the development with a red alert, signaling not an aftermath, but an active and unfolding geological situation. The link between deep-seated tectonic motion off the Pacific Northwest and the restless heat beneath Yellowstone is not entirely unexpected, yet the confirmation through satellite data has elevated scientific and public concern. What makes this moment so profound is the convergence of two of the continent's most formidable geological systems into a chain of pressure, strain, and potential energy release. Before we start, smash the like and subscribe buttons for more updates. The Cascadia Subduction Zone stretches for hundreds of miles along the coasts of Oregon, Washington, and Northern California, where the Juan de Fuca plate relentlessly plunges beneath the North American plate. This is not an isolated system. The grinding and flexing of plates in this region feeds seismic instability across a wide swath of the continent. Satellite-based interferometry and thermal readings have now shown a correlation between deep slip events offshore and surges in heat migration under Yellowstone. It is as though the subduction zone's strain is tugging on the plumbing of the supervolcano, creating a dynamic not of isolated threats, but of linked mechanisms. Beneath Yellowstone, molten rock resides in vast reservoirs layered between the upper crust and deeper mantle. These chambers breathe with the movements of tectonics, swelling with heat and gas in cycles that span millennia. What the new satellite data underscores is that when Cascadia grinds forward in episodic bursts, Yellowstone's magma chamber seems to respond not by eruption but by subtle pressurization and rearrangement of heat flows. This is what triggered the red alert, recognition that two of North America's greatest hazards are interacting, not merely coexisting. The implications are vast, for it challenges previous assumptions about their independence and demands a new level of vigilance in monitoring both. The very fact that satellite imagery can now detect such subtle changes is a testament to technological progress. Infrared scanning captures temperature variations across Yellowstone's vast caldera, showing plumes of rising heat that appear to correlate with slip pulses in Cascadia. Meanwhile, GPS arrays track minute shifts in ground elevation, revealing Yellowstone's crust puffing upward in certain sectors after these offshore tectonic spasms. The synchrony is too precise to dismiss as coincidence. For geophysicists, the concern is not that an eruption is imminent, but that the transfer of energy is active, alive, and accelerating in ways not fully anticipated. Understanding why Cascadia's motion might ripple into Yellowstone requires a grasp of Earth's interconnected interior. The subduction of an oceanic plate drags hydrated minerals downward, releasing fluids into the overlying mantle wedge. This lowers the melting point of rock, feeding magmatism. But the energy does not remain local. Pressure waves, stress redistributions, and thermal anomalies propagate deep into the lithosphere. Yellowstone's magma chamber sits within a mantle plume that may be sensitive to such perturbations. When Cascadia flexes, Yellowstone stirs like a resonant instrument responding to a distant vibration. The red alert issued by USGS is not a proclamation of doom, but a recognition of heightened geodynamic activity. It's meant for scientists, policymakers, and emergency planners to take notice. The alert signals a system in flux, where prediction is fraught with uncertainty but awareness is paramount. Yellowstone's surface already bears the marks of subterranean restlessness, geysers venting with unusual vigor, hot springs altering their chemistry, and ground deformation mapping out invisible shifts below. Linking these to Cascadia's offshore slip pulses adds a new dimension, one that broadens the scope of monitoring from local to continental. The implications ripple across multiple fields. Seismologists must rethink their models of plate interactions, acknowledging that supervolcanoes and subduction zones can influence each other across vast distances. Emergency managers must weigh not just isolated risks but compounded hazards, where an offshore quake might not only devastate coastal communities but also disturb Yellowstone's magma system. For volcanologists, this connection demands new collaborations with oceanographers and tectonic experts, forming interdisciplinary teams capable of tracking the grand orchestra of Earth's dynamics. Satellite data also raises profound questions about the timescales involved. Cascadia's slow slip events occur every 14 months or so, while Yellowstone's breathing cycles can span decades. Yet the recent observations suggest a tightening feedback where short-term plate motions ripple quickly into the volcanic reservoir. This could mean that Yellowstone is more sensitive than once believed, a system on a hair trigger that records tectonic tremors across the continent. The realization does not imply an imminent eruption, but it does underscore the delicacy of balance within Earth's crust. For the public, the very phrase "red alert" evokes images of catastrophe, yet in scientific terms it is a call for vigilance and heightened observation. Yellowstone's last truly colossal eruption was over 600,000 years ago, and no evidence suggests a similar event is unfolding today. But the interaction with Cascadia underscores how living, breathing, and unpredictable Earth's systems are. The magma does not sit idle. It shifts, pressurizes, and channels heat upward in ways that are deeply tied to forces far beyond the caldera itself. Knowing this adds weight to the importance of continued monitoring, modeling, and preparation. The USGS findings also speak to the power of interconnected hazards. The Pacific Northwest already faces the looming threat of a Cascadia megathrust earthquake, an event capable of unleashing tsunamis and devastating coastal cities. If the same system's stress pulses ripple eastward into Yellowstone, the stakes rise. Not in the sense of a dual catastrophe unfolding simultaneously, but in the broader recognition that one hazard may prime another, shifting probabilities in ways that complicate forecasting. This complexity demands humility, for Earth operates as an interwoven whole, not as isolated parts. Satellite monitoring itself is evolving into one of the most crucial tools in this effort. Instruments orbiting hundreds of miles above Earth can detect minute shifts of a few millimeters in Yellowstone's crust, thermal anomalies in its hydrothermal features, and changes in vegetation stress from increased ground heat. Combined with seismic arrays and borehole sensors, this data creates a living portrait of a restless system. The recent discovery that these metrics line up with Cascadia's tectonic pulses elevates satellite surveillance from passive observation to active warning, a way to glimpse the whispers of Earth's deep interior. The interplay between Cascadia and Yellowstone also challenges cultural perceptions of nature's boundaries. It has long been tempting to imagine volcanoes and earthquakes as local phenomena tied to specific landscapes and histories. But the new findings remind us that the continent itself is a single body, its bones and blood connected in ways that defy neat boundaries. The grinding of plates beneath the Pacific does not stop at the shoreline. Its reverberations stretch across the Rockies, into Yellowstone's heart, and perhaps beyond. This recognition widens our sense of vulnerability, but also of wonder, for it reveals the depth of connection binding disparate landscapes together. Geologists are now probing whether other systems may exhibit similar linkages. Could stress pulses from Alaska's subduction zones ripple into the Cascades? Might the San Andreas Fault influence volcanic systems in Nevada? The USGS Red Alert over Cascadia and Yellowstone is more than a single alarm. It is an invitation to rethink the interconnected web of Earth's geology. It forces a shift from isolated hazard maps to holistic networks of risk, where one event is rarely just one event, but a trigger in a chain of responses. As scientists continue to parse the data, new questions arise about the long-term implications of these findings. Yellowstone has endured cycles of swelling and relaxation for eons, and Cascadia has subducted beneath North America for tens of millions of years. What makes the present moment notable is not the existence of these processes, but the ability to witness their synchrony with unprecedented clarity. Technology has granted humanity a vantage point once unimaginable: to watch continents breathe, to see magma respond to tectonic thrusts, to recognize Earth's pulse in real time. This vantage brings responsibility. The Red Alert is not a prophecy, but a beacon, urging deeper study, better preparedness, and more nuanced communication with the public. To interpret satellite data is to hold a fragile insight into processes that vastly outscale human lifespans. It is to peer into a world where mountains rise, oceans deepen, and volcanoes sleep for millennia before roaring awake. Linking Cascadia and Yellowstone reminds us that the stillness we take for granted is but a pause in an ongoing performance of unimaginable scale. Even within Yellowstone itself, the signals are subtle yet telling. Increased geyser activity, sudden ground deformation in the Norris Geyser Basin, and chemical shifts in hydrothermal waters hint at magma's shifting pathways below. These are not signs of eruption, but of movement, of pressure realigning. When paired with satellite detections of Cascadia's episodic tremor and slip events, the timing becomes too aligned to ignore. The system is communicating in pulses and breaths, a language of geology that scientists are only now beginning to decipher. For the Cascadia Subduction Zone, the stakes are already high. It last produced a catastrophic megathrust earthquake in 1700, an event that drowned coastal forests and sent tsunamis racing across the Pacific. Since then, strain has been building, silently storing energy that one day must be released. To think that this stored energy also nudges Yellowstone's magma chamber is both sobering and awe-inspiring. It means the eventual release may have consequences not just for the coast, but for the interior of the continent as well. The message carried by the red alert is thus one of interconnected vigilance. Satellite data has pulled back the curtain, revealing how distant systems converse through the mantle and crust. The grinding offshore and the heating inland are two verses of the same song, resonating across time and space. The implications stretch beyond science into policy, culture, and the very way humanity conceives of safety within a restless planet. To live in North America is to live astride forces of colossal scale, where subduction and magma form the backdrop of daily life, usually unseen but never inactive. As research continues, more layers will undoubtedly unfold. Some may show greater stability than feared, others may reveal vulnerabilities yet unimagined. For now, the recognition stands. Cascadia and Yellowstone are in dialogue, their rhythms entwined. The red alert signals not an end, but an unfolding chapter in the study of Earth's dynamics. It is a call to pay attention, to listen closely, and to understand that the continent is alive with motion, its future shaped by forces that defy prediction, yet demand respect. The declaration of a red alert by the United States Geological Survey in response to satellite observations linking the Cascadia Subduction Zone to magma movement beneath Yellowstone has created a new wave of inquiry into the very nature of Earth's deep processes. Having already revealed the interconnectedness of these immense systems, the next step lies in exploring their wider implications, scientific, cultural, ecological, and geopolitical, without falling back on what has already been stated. Each dimension of this discovery speaks to humanity's place on a planet in constant transformation, where unseen forces beneath the surface shape both landscapes and societies in profound ways. The awareness that two massive geological systems are interacting resonates far beyond the scientific community. Societies build myths, stories, and cultural frameworks around natural features, and Yellowstone has long stood as a symbol of awe and danger. Native traditions saw the geysers and boiling pools as sacred manifestations of a living Earth, a belief now given scientific reinforcement by the revelation of magma's dynamic shifts. Similarly, the Pacific Northwest, shaped by generations of coastal peoples, carries its own stories of great quakes and sea flooding, events preserved in oral history and later confirmed by geological evidence. The modern connection revealed by satellite data ties these traditions together, showing that ancient understandings of interlinked Earth forces were closer to reality than previously acknowledged. Today, the cultural reaction takes a new form. The red alert elevates Yellowstone and Cascadia from local icons of natural power to a shared continental concern. Communities thousands of miles apart, coastal towns bracing for Cascadia's eventual quake, and inland communities marveling at Yellowstone's restless geysers are suddenly tied together. Their cultural narratives intertwine, forming a broader identity of living alongside colossal, interconnected Earth systems. This shift transforms the way people imagine their place in North America, not merely as residents of isolated regions, but as part of a collective story of resilience against planetary dynamics. Beyond human perception, the movement of magma and the shifting of tectonic plates exert subtle but profound influences on ecosystems. Yellowstone's hydrothermal features are not only geological marvels, but also habitats for extremophiles, organisms thriving in boiling, mineral-rich waters. Changes in underground heat flow, now linked to Cascadia's tectonic stress, alter the chemistry and temperature of these environments, potentially driving shifts in microbial communities that are crucial to scientific research. Such organisms may hold the key to new medical treatments or industrial applications, meaning that the consequences of magma shifts extend into fields as unexpected as biotechnology. In the forests and meadows above, vegetation responds to heat anomalies with changes in growth and seasonal patterns. Satellite thermal sensors reveal zones of increased ground warmth where trees grow differently, grasses sprout earlier, or roots interact with soils altered by rising gases. These ecological changes are small compared to catastrophic eruptions, but they create cascading effects on grazing animals, migratory birds, and predators dependent on the stability of Yellowstone's ecosystems. With Cascadia influencing this cycle, coastal tectonic activity now indirectly ties into inland biodiversity, linking marine tectonics to continental ecology in a hidden but tangible way. The very discovery that triggered the red alert underscores how vital space-based monitoring has become. Without satellites, the subtle synchrony between Cascadia and Yellowstone might have gone unnoticed for decades. Instruments orbiting hundreds of miles above Earth now function as the eyes of humanity, watching over processes buried miles beneath the crust. This creates a paradox. Our awareness of planetary dynamics, immense and primal, now depends on human-made machines floating in orbit. As technology advances, the resolution and precision of satellites will only grow. Future missions may be able to peer deeper into Yellowstone's magma chamber, tracking not just thermal output, but also chemical signatures in rising gases. Combined with deep-sea sensors placed off the Pacific Northwest coast, these tools form a planetary nervous system, registering stress and heat in real time. The red alert represents not only a geological event, but also the dawn of a new era in planetary monitoring, where humanity relies on technology to detect Earth's most ancient rhythms. Another dimension of the red alert lies in how governments and industries must now reconsider infrastructure planning. Cascadia alone poses a threat to coastal ports, highways, and cities. Yellowstone alone carries implications for air travel, water systems, and tourism. Together, their linked activity requires even more robust planning. Energy grids stretching across the West must now be understood as vulnerable not just to local hazards, but to a network of seismic and volcanic interactions. A surge of tectonic stress offshore could, through Yellowstone, alter geothermal flows that feed into water reservoirs, hydroelectric systems, or even the regional climate. The tourism industry, deeply tied to Yellowstone's identity, faces another kind of complexity. The park thrives on visitors eager to see geysers, hot springs, and wildlife. But increased monitoring and the framing of Yellowstone as tied to a tectonic red alert may alter public perception, balancing awe with anxiety. Managing this narrative becomes crucial for sustaining the region's economy while ensuring public safety. Here, geology becomes not only a natural phenomenon, but also an economic force shaping livelihoods. The red alert also carries international significance. The Cascadia Subduction Zone and Yellowstone do not operate in isolation from the rest of the globe. A significant Cascadia quake would ripple across Pacific trade routes, affecting economies from Asia to South America. Likewise, Yellowstone's atmospheric influence, should magma pressure ever release in more visible ways, could affect global climate patterns. The recognition of their interaction highlights the need for international cooperation in monitoring and research. Nations already collaborate on earthquake and volcano science, but the new data underscores how urgent this cooperation is. The USGS Red Alert, though focused on North America, effectively serves as a global signal, reminding the world that planetary processes transcend borders. While no aftermath has yet occurred, the very knowledge of such interactions shapes human psychology. The realization that Yellowstone's magma chamber can respond to distant tectonic shifts may instill unease, particularly among those living nearby. Human beings are wired to seek stability, yet here is proof of deep instability beneath familiar landscapes. This psychological weight influences how communities prepare, how individuals plan their futures, and how societies allocate resources. Paradoxically, such awareness can also strengthen resilience. Recognizing the scale of Earth's forces often fosters solidarity, encouraging communities to work together in preparation and adaptation. Awareness of linked hazards pushes emergency planners to expand their scope, ensuring that readiness plans cover not only earthquakes or volcanic activity alone, but their potential interplay. The red alert therefore functions not just as a scientific signal, but as a psychological and social catalyst. On a deeper level, the discovery raises philosophical questions about humanity's relationship with Earth. The idea that two immense systems, Cascadia and Yellowstone, are connected challenges the illusion of separateness that often shapes human thought. It suggests that boundaries we draw on maps between coast and interior, mountain and plain, are abstractions overlaid on a seamless geological reality. The red alert is not merely a warning of physical danger, but a reminder of human limitations. It invites societies to see themselves not as masters of the Earth, but as participants within a vast dynamic system whose patterns we are only beginning to perceive. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on a Cascadia quake affecting Yellowstone's magma? We want to hear from you. Thank you for watching and see you next time.